So I asked you to go to page 18 first and foremost. So if you want to turn to 18 real quick, I will just walk you through it. I won't actually solve the whole thing because we don't have time to do that. But I asked you to calculate the angle B here, this one. And what I did is if there's ever a height, I tend to see, can I work without it first? And so this is the triangle that results, it's that big one, right? The total roof here. And using sine law, I get this. Some of you use sine law with this right triangle here. I was walking around and you got a slightly different answer. That's okay. You're okay. It has to do with rounding, right? So you are good. Either way is fine. And then to find A up here, like by A I mean this whole angle up here. I just go 180 minus the two angles that I already know, and I get this. Okay. Now let's go ahead and classify. Right. So if you want ABC, which is this one, this triangle, you know this is a right angle here. Okay, if there's a right angle, a 90 on this side, there's a 90 on that side. They're supplementary, guys. Sometimes it comes in a slant, right? But this it's a vertical here. So how could you have done that one? I knew that this is a right triangle for sure because of this. I needed to narrow down if it's scalene. So given that this is 19.19, I use the sum of 180 to come up with that one. So I figure out all angles are different, right? And that's how I can actually figure out that it's scalene without having to solve for any other sides. Okay, you could have used Pythagorean theorem. There's nothing wrong with it, but it's probably more work. ACD is the other side. This is 25. I use sum of 180 to get the other one. All three angles are different, therefore all three sides will be different. And obviously this is a right triangle because of that 90. And here we calculated that top angle. That turns it into an obtuse. And since all angles are different, it's a scalene. Okay. And I make a note saying that knowing all angles allows you to classify without finding side lengths. Okay. So if you do know all angles, you actually don't need to solve any sides. If you know all sides, you do need to check at least one angle to see if it's obtuse, right, or acute, just to rule out. Let's go to 20 where the bridge question is found. And so what I did here on 20, right, this is 1113. We're told that the height of the bridge is 8. Okay, so I took this side here. Maybe I'll use the highlighter. I kind of cut this one out and worked with it here. And I use a good old Pythagorean theorem. You're missing a leg here. So we find out that, and the reason why I used 4 decimals is just because I'm going to use that still in my work. And I realize if you look at the bottom here, there are 6, like, right? This is the same as this section as this. Right, because there's 1, 2, 3, 4, 5, 6. So 6 sections of that, right? So I take this and just multiply it. And so giving me the total length of 47.88. Okay. Then I do some classification as well, and you do see that there's an isosceles triangle here. I think the question is actually referring to this one in particular, but you do know that these two sections transfer over to the top here. So you just go 7, like this, 7.98 times 2 to get this stretch here, okay, at the base. So I get 15, 11, 11. So this is going to be an acute isosceles. And obviously, if you split this in half, it's going to be a right scalene because if this is 8, This is 7.98. So technically it's not quite an isosceles. Okay. And anyways, I'm just going to leave it there. I thought I'd do a few more for you there. More challenging, of course. And obviously everything up to 22 is posted on Google Classroom. Okay. We're going to go back to quadrilaterals, okay? Four-sided shapes. So we're going to go to page 25. I'm actually going to name this video Quadrilaterals. Just have a little bit of extra triangle to warm up, okay? All right, let's dive in. Now we're going to do, this is lesson time, okay? So quadrilaterals, we call them quads. Four-sided shape, this is on page 25. Have some highlighters because I'm going to actually do some sketching inside the shapes. And so for the quadrilateral family, you've got three branches, guys, okay? It's not too complicated if you just understand there's three branches. This is the branch that has most shapes in it, as you can tell. Kite is on its own little planet. And then trapezoids, there's only a right trapezoid or isosceles trapezoid that we deal with. So these two branches here, they're not all that complicated. Here, there's more action happening in here, okay? There's some similarities and some differences. Something that makes a rhombus very peculiar as opposed to a parallelogram, and so we're going to study that in a bit. This, I don't know if I asked you to do this, the arrow, like this, these shapes here, they all share this in common. They all have this in common, so it pertains to all of them. They have two pairs of parallel sides. They have two pairs of congruent sides. The congruent part I did not really want to do on here, but I will, okay? So I'm going to use a green highlighter. And I'm going to just go green like that. It's good to go green these days, right? Right, so these two are the same. And these two are the same in length, okay? Length I'm talking about. So we'll do that for all of them, right? These two are the same. These two are the same. You can't just put one mark all around because that's not accurate. Not always. Okay, so about the square, guys. What do we know about all four sides in a square? They all are equal in measure, actually. But I still want to say that the fact that they have two pairs of congruent sides still applies, right? This would be a pair, this would be a pair, okay? So now let's zoom into each one of them in particular. So go to page 26. I don't know, the pattern I want you to see here is that a rectangle and a parallelogram, the main difference is that a parallelogram would be slanted. A rectangle has 90 degrees all around. A rhombus is slanted versus a square has 90 degrees all around. Okay, so let's start with the first property here. The first property would be that this side is the same as that one. I like markings more than writing, okay? And that this side is the same as that one. Okay, that's a parallelogram. It has two pairs that are parallel. That's why the name is called parallelogram. A rectangle has the same thing. This side is the same as that side. This side measures the same as that side. Now let's go down to the rhombus and the square. How are they related? Well, a rhombus has all four sides, like if you want to be very specific, all four sides measure the same. It is the same thing with the square. All four sides are congruent. Okay. So I will say this. Let's go rhombus and square. All four sides. I'm not going to write out congruent anymore. I'm just going to do that. All four sides are congruent like that. But you could still say it has two pairs of congruent sides. You could still say that and not be wrong. Okay, but if you want to be very specific and say, no, this is a rhombus, you would want to tell me that all four sides are the same. Okay? All right, so we kind of compared them side by side. There's something that these two have in common here. And it is the angles, so the 90s. Four times 90 is 360, right? So it also adds up that it has four right angles. Same with this one. Four right angles. Hope you can see the whole thing there. I know it's a little spread out, but what else do I want to talk about? I'm going to talk about diagonals. And this is where I have a red and a blue pen for this. Okay. A red and a blue pen. And I'm going to use a ruler as well. If you have something to draw a straight line, that'd be great. Diagonals go across the shape. Okay. So a parallelogram, if you were to connect this corner with that corner, that is a diagonal there. Okay. And if you connect this corner with the corner opposite to it, you have another diagonal. So I'm going to specify that. A long and a short diagonal. And watch what I'm going to do. I'm going to color code. Which one is the longest, the red or the blue? It's the red, actually. See how this is pinched here? Like the more you slant it, the more pinched it is, the longer the red one will become. But that is always the longest, and the short one is blue. That's why I use two different colors. Okay. The same thing is true about a rhombus. Okay, so we're going to go down to a rhombus. It's also slanted, so there's therefore a long and a short diagonal. A long and a short diagonal. Like that. And this is where it gets interesting. Okay? If you look on page 25, if you wrote this down, it says diagonals. What's that word? Bisect each other. Do you see that? So that means that the diagonals, when they meet here, they cut each other in half. Okay? So what I need to do, watch this, guys. I already used 1, 1, 2, 2 for lengths. So if I want to say that this stretch is the same as this stretch, I have to use 1, 2, 3, 1, 2, 3, right? So I'm saying that if this is where they meet, this is the same as that in terms of length. Okay? And how many lines am I going to have to use for the blue stretch? I used up 3 already, so I'm going to have to use 1, 2, 3, 4. 1, 2, 3, 4. Does that make sense? Okay, next here. The same with the rhombus. I already used, because all sides are the same, I can use the 2 here and the 2 there. And this is 1, 2, 3, 1, 2, 3. Okay, and they cross here. All of them, the diagonals bisect, all of these. However, there's a long and a short, a long and a short, right? Very interesting stuff, I know. This is just to help you understand what's happening. A rectangle and a square, they actually have the same diagonal. Like, so I'm going to use a different color. I'm using a green highlighter because they are actually equal in length. Same with the square. But they still bisect each other. That fact doesn't go anywhere. Okay? So I've used 1 and 2 already, so I'm going to go like this. Watch. 1, 2, 3, 1, 2, 3. But I can also go 1, 2, 3 here, and I can go 1, 2, 3 there as well. All of these stretches are exactly the same. Not the case with the slanted shapes. Okay, remember this. They always cut each other in half. But only the ones that have 90-degree angles, only those shapes, end up with diagonals that are all exactly the same in length, which means when they cut each other, all of those cut up pieces are going to be the same in length. Same with the square. I already used up 1 marking, so I can go 1, 2, 1, 2, 1, 2, 1, 2. Okay? So I'm going to write that down here. Diagonals are congruent. Okay? Same with the square down here. Diagonals are congruent, so they're actually the same in length. And I'm going to highlight them in green. Is that going to backfire? Is that going to make it hard to see or what? Okay. Diagonals are congruent. And one last thing. You ready for this one? I'm going to use orange. Orange, you're glad it's Thursday. Okay. Exactly. There's something special about these two, and it's that when they meet here, they form a 90, the rhombus and the square. So there, I don't know if you've noticed that there was relationships that are across this way, and sometimes it's across that way. But that is the very important distinction, guys. Okay? So diagonals are perpendicular. I'm going to write that down for the other one as well. So I'm going to, sorry there. Diagonals are perpendicular. I'm not going to write out the whole thing again for the square. But diagonals are perpendicular. I'm gonna highlight that in orange. Okay. What is perpendicular? I know you're probably asking. Meet at 90 degrees. Meet at 90 degrees. That's what that is referring to. Question. Are there still, do all of these have 2 pairs of parallel sides? Do all of these shapes? Yes. So now it's like, yeah. I don't add the notation because I already did that on the previous page. I don't add, otherwise it's going to get way too busy. Okay, but that is also true for all of them. Have I covered everything? Yes. That's it for this part. I'm just gonna, can I do, you do whatever you need to do, okay? But I'm gonna do this. The pink right angles, I have that on mine, so that just tells you that 4 angles are right angles. Some of you are gonna be like, I don't need that. I don't need the pink. That's up to you. It's up to you what you want to do there. And you know what? I used to give a student a list, a table. I'm not kidding you. It's like a whole page with all of the properties. And it was so overwhelming. It's like, if you just know these ones, you're going to be fine. Okay? You're going to be just fine. Okay, the last and the coolest of them all is this part. Watch. Am I going to do this here? Yeah, I will do it here on this page. You're awake for this part? Because all lines are parallel, that's why this works. If I were to take this angle and the one down here, I would always end up with 180 degrees. Okay, so if this up here is 50, sorry, that doesn't make sense. If this is 130, then this is 50. If this is 100, then this one is 80. Like, that's always going to be true. Very, very important for you to know. I would make sure I make those. I will do the same thing here. Can you tell that it's the case on the rectangle? What's 90 and 90? 180. That's right. 90 and 90. So for all of these, on either side, that is, if you know one of these angles, you will also know the other one. Okay. It's the sum of 180 on the one side. Yeah. Yeah, that's funny. All right. Let's keep going. Let's keep going. We gotta go along with the plan here. 27. Okay. Real quick here, and you will just have to look at the notation. So we know that this side is parallel to that side. So just one pair. The snowblower is going to interrupt, but anyways, I'm going to put at the top of this whole thing. At the top of this whole thing is that they have one pair of parallel sides. Okay, you need to know that both of the trapezoids, this is the trapezoid family. It's way on the right side. So we do this and this, and we do this and this. Okay. What else do I want to say? Oh yeah, the right trapezoid, watch this, has 2 right angles. Why do I, oh yeah, okay. And that's about it for this shape. 2 right angles, and guess what? The 180, I'm going to do that later. It's also going to be true here. For an isosceles trapezoid, we know that the diagonals are the same in length. Does isosceles ring a bell? Think of this as an isosceles triangle that somebody just cut off the top, and you're left with the base. So this is an isosceles trapezoid. You thought it was only specific to triangles, not the case. Isosceles trapezoid. So these diagonals are the same. Okay. diagonals are congruent. Do you think they bisect? Do you think they cut each other in half? It doesn't look like it, does it? So I want to make sure you understand they don't bisect. They do not cut each other in half. Okay. They have, however, two pairs of congruent angles. Two pairs of congruent angles, and here they are. This one down here is going to be the same as this one here. And I'm just going to stick with pink on this one, whatever you're using, okay? Which means that, watch this, guys, the top here, this one, will be the same as this one here. Okay, so that's where this comes in. And diagonals are congruent. That's the green part. Okay. Anything else that I need to tell you here? Yes, this part, my favorite part, because it comes in so handy. These two are 180. That's because of the parallel sides. And I'm going to make sure you understand it's this side as well. Okay. So if you know this angle, you can easily find the other one because they add up to 180 every time. Every single shape except for the kite, you can use this with. They mean business. Okay. Anything else? Oh yes. You ready for this? If I ever ask you for the area of a trapezoid, did I give you that already? I feel like I did. I will do it one more. A plus B, okay. So I'm just going to go A, B, and this is the height. So it's A plus B times height divided by 2. Just in case you missed it, there it is one more time. Last one, the kite, and then we're going to start sketching these things. And I'm going to the kite. Anybody ever fly a kite? Is that still a thing we do these days? You did? And in South America, I used to make my own with like garbage bags and like bamboo reeds. I just make my own. And we would sand up like a whole roll, a spool of, so like the kite was as small as my thumb by the time it's up there. And you just left it up there all day, right? And then sometimes you would fight with your friend and you would kind of like do fights and they would tangle up and fall down. Anyways, what does that have to do with this? Well, it's a kite. Talking about kites. If you missed anything, we can always go back. But I just want to make sure I finish this before we go home. Kite. I want you to think of it. Don't tell me that this is what it is. Think of two isosceles triangles that are stacked. Oops. Like this is an isosceles triangle and this is one and they're stacked. That's what I want you to think of. Because that helps students sometimes come up with the properties. Okay. So what can I say? What can I tell you about them? They have two pairs of congruent sides. Okay? Two pair of congruent sides. And this is what I mean by that, that this side is the same as that one, and this side measures the same as this side. I might just use my regular yellow highlighter for that one. I need things to stick out for me, so that's why I'm doing that. Another property about them is that diagonals are, what is this here? Anybody know what this symbol means? Perpendicular. Have you ever seen that symbol before? Yeah, some of you have. Perpendicular is they meet at a 90. Okay, so that's what I'm going to use orange. So I'm going to say the two diagonals that are represented by the dashed lines they meet at a 90. That's a pretty cool property. Short diagonal bisects. What? What does that mean? Gibberish. Okay, I would say short diagonal bisects. So this one here, this stretch is going to be the same as that stretch. Like if you go to the center, this little stretch and that stretch is going to be the same. And last but not least is one pair of congruent angles. So this one doesn't really have a pattern. Doesn't really have a pattern. I'm going to use green for that one. What do all quadrilaterals add up to when it comes to angles? Yes, they're always 360, all of these. Look at this. Look at the fact that it's two isosceles triangles stacked. Would it make sense that the green angles are the same on this kite? Because if the base of if this is an isosceles triangle and the base angles are the same, and then you take another isosceles triangle where the base angles are the same and you stack them, it stands to reason that, right, the whole thing should be equal. But the top and bottom are not, okay? The top and the bottom are not the same. Okay, before we go, we're going to sketch a few. Okay, before we go, we're going to sketch a few, so don't practice yet. It's going to be, if you know how to sketch them, and I will tell you this, usually you only need to know at least two properties. Like if you know two properties of any shape, you're going to be fine. Okay? So let's go over to 28. And of course, you can cheat now. You can look at your notes. 28 says, and everything we don't finish, 28 to 30 or so, I'm going to ask you to do for homework. Make sure you clearly indicate properties, state or use markings. And I want you to identify two properties. Make 3 versions of each example. That is important to me. So for example, a kite. You should know after a while what a kite looks like. Doesn't have to be pretty. So one property would be, look at the one, 2 pairs of parallel sides, not parallel, congruent sides, okay? So you go dun, 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 dun. That's one property. So you get 1 out of 2 marks already. What's another property that I could use? Oh, diagonals meet at a 90. Okay, so just go and put a 90 there. That is 2 properties right there, guys. 2 properties. One more. Or draw another kite. And this one you're like, let's see. I'm going to start with diagonals are at a 90. And I know that the short diagonal cuts in half, correct? Of course you remember. So you go like this. Are those 2 properties? Yes. Or, I think you get the gist of it. You can say this angle is the same as that one. And these 2 sides are the same, as well as these two sides. You're done. Okay, so all three of these versions would have gotten full marks on this one. You can write it out if you want, if you prefer to write it out, but I think markings is the way to go. Okay, it's much faster. So pages 28 to 30, guys, it will take you minutes, but it will help you out big time to start thinking about these things. Okay. Thank you very much. Have a great rest of your day.